Hello, ladies and gentlemen. I am once again asking you to factor. And for these problems, I made a little flowchart. So what we're going to do is we're going to practice going through all of the things that you might be asked to do when it comes to factoring in Algebra 2. I think that rhymed, so that's a poem. Great. Okay, let's go through the possibilities and then we'll actually do some examples. So every time you factor, the first question you should always ask is there a GCF? And if the answer is yes, then you need to factor out the GCF. Okay, every time, no exceptions. That's your main first line of attack every single time. Once you've determined if there's a GCF or not, then you have to kind of ask yourself, how many terms am I working with? Because this sort of determines your next course of action. If you have two terms, then it's possible they are talking about sum and difference of cubes. That's the new one. Or it's possible that it's dots. And if it's neither of those, fine. But those are the two things that you look for past GCF. If it has three terms, we're going to split the middle if it's in the quadratic form. And I'll remind you that the quadratic form, a quadratic would look like this with 2 and 1. And I'll just make up a number here, whatever it is, doesn't matter too. Okay, that's in the quadratic form, but other polynomials that are in the quadratic form are anything that's the same ratio, like 4 and 2 would be the quadratic form. 6 and 3 is the quadratic form. Anytime that this leading exponent is twice this middle term, then you split the middle just like you always split the middle, and then you'll just have higher degree factoring. And if there are four terms, then you're going to factor by grouping, and that's the only strategies that you can have. Okay, so we're either going to look for sum and difference cubes or dots if it's got two terms, we're going to split the middle, or we're going to factor by grouping. Okay, we always look for GCF. So for the first problem, we're going to say, is there a GCF? And the answer is yes. These are both x squareds. And x squared times x gives you x cubed, and then times 1. This is degree 1, you're done. You can't do anything else. So in that problem, it was just GCF. That was the only thing you could do. Second problem, is there a GCF? 2 and 50? Yup, GCF. So if I factor out a 2, I have x squared minus 25. And now I go back to the flow chart and I'm like, all right, two terms. Are they both perfect cubes? No, 25 is not a perfect cube. X squared is not a perfect cube. So no. All right, are you subtracting two perfect squares? Yeah, x squared and 25 are both perfect squares. So then that means this must be dots. Okay, so dots is you figure out the square root of each term. The square root of x squared is x, and the square root of 25 is 5. And then these are called conjugates. One gets a plus, one gets a minus. So that's the factored part in blue. Bring the 2 down. Now we have x to the first, so I know I am completely factored. I'm done. Let's try again. For number 3, is there a GCF? They're all even. There's at least a 2 I can factor out. Now I have 3x squared plus 8x plus 5. And now I go back and say, okay, I have 3 terms in this problem. I just did GCF, 3 terms. Is it in the quadratic form? Yes, 2 and 1. So I'm going to split the middle. I'm going to find numbers that multiply to a times c. And in this problem, 3 times 5 is 15. Find numbers that multiply to 15 and add to the middle. The middle is 8. Okay, I'm only factoring what's in blue. I've already handled the 2. So 15, 1 and 15, or 3 and 5, 5 and 3, it's one of those. It's 3 and 5, okay? So I'm going to split the middle, 3x squared. Instead of 8, I'm going to put plus 3x and plus 5x, okay? And that's those two right there. Now I factor by grouping. So the GCF of the first two is 3x, and I'm left with x plus 1. Bring down the plus sign. The GCF of 5 and 5 is 5, and you're left with x plus 1. So the factored form is 3x plus 5. They share x plus 1. That's the whole idea. And then don't forget that 2 that's been hanging out there. Okay. So we did GCF and split the middle in that problem. Okay, let's try another one. GCF. You always look for GCF. Yes, there is a 5. And now it's x cubed plus 8. X cubed plus 8. So I go back to my flow chart. Let's see. I have 3 terms, or no, I have 2 terms. Oh, wait, where did that go? Okay. I have 2 terms, x cubed and 8. So, are they both perfect cubes? Yes, they are both perfect cubes. So that means I'm going to use the sum and difference of cubes formula. And that's what we've been working on the past few days, so I'll write that off to the side just as a reminder. It's a squared, AB, b squared, and we use SOAP. So since it's plus, we'll say same, opposite, always positive. This is the same, that's the opposite, that one will always be positive. So if this is plus, that's minus. So we got to figure out what a and b are. The cube root of x cubed is x, and the cube root of 8 is 2. So you figure out what a and b are. Now I'm going to do a times itself. X times itself is x squared. A times b, x times 2 is 2x. And b times itself, 2 times 2 is 4. And I already have the signs. Same, opposite, always positive. Plus is the same. These are always opposites, and that's always positive. Bring down the 5, you are finished. Something that's worth knowing, if you do sum and difference of cubes, this will never be factorable. You will always be finished when you get to that step. Okay, nothing multiplies to 4 and adds to -2, so you'll never be able to factor that part of sum and difference of cubes. Let's try another one. Number 5, is there a GCF? No, there's not a GCF in this problem. Okay, so what else can I ask? There's 3 terms. Is it in the quadratic form? Yes, 4 and 2, that's double. So this is like split the middle again. I have to find numbers that multiply to 1 times 6 and add to 5, which could be 1 and 6 or 2 and 3. It's 2 and 3. So watch though, when you split the middle, it's a little bit fancier. X to the 4th plus 2x squared plus 3x squared plus 6. You see how those have to add to x squared? So when I do my grouping, the GCF is x squared, and I have x squared plus 2. Bring down the plus sign. The GCF there is 3, x squared plus 2. And since they share x squared plus 2, that's one of my factors, x squared plus 2, and the other is x squared plus 3. Now we need to be like, can I keep going? There's 2 terms here. Are they perfect squares? No. Are they perfect cubes? No. Same thing here. These aren't perfect squares or perfect cubes, so you are completely factored at that point. All right, one more. So let's see. There is no GCF. There's 2 terms. Are they perfect cubes? No. Are they perfect squares? Yes. Are you subtracting? No. Prime. This is prime. You can't do anything with this. Prime numbers can't be factored. Prime polynomials can't be factored. There's nothing we can do here if it's x squared plus 4. If it were x squared minus 4, I could factor it. But I've exhausted all my options, so I just can't do anything with that problem. If you practice that when you're factoring and it's all mixed together, it's sort of the best way to organize your thoughts. Every problem kind of has the same flow to it. And that's why you have the flow chart. So get your homework done and smash that like and subscribe.